Problem number 7 states, right triangle DEF with side lengths of integer length has a perimeter of 40 meters. Semicircles are drawn with diameter DE and diameter EF as shown. If arc DEF is a semicircle, what is the total area of the shaded regions? So we know that the perimeter of this triangle DEF has 40 meters in perimeter. And we know that all side lengths are integers. Knowing this, they want us to find the area of the shaded regions. So first thing that we are going to do is we are going to find the side lengths for this triangle. Because we know that all the side lengths are integers, and we know that this is a right triangle, and the perimeter is 40 meters, we are going to start by finding our perfect Pythagorean triples that add up to be 40. So I'm going to start with 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17. Okay, so we have found 8, 15, 17 works. Now, actually I wasn't really explaining it as I was listing it, but what I was doing is in my head I was calculating if they added up to be 40. And these first 4 did not, but this last one did. So we know that DE is 8, EF is 15, and DF is 17. Knowing this, we are going to now find the area of the semicircle, the largest semicircle right here. So the area of that would equal 1/2 pi r squared. So we know 1/2 pi, the radius is half of the diameter, which is 17 over 2 squared, and that gives us 1/2 pi times 289 over 4. So that gives us 289 over 8 pi. So we know that is the area of the largest semicircle. So I'm just going to jot down this right here. Now erasing that, I'm going to find the area of triangle DEF. To find the area of a triangle, it's 1/2 base times height. So 1/2 15 times 8, which gives us 60. So we know this triangle right here has an area of 60. The reason why I am finding the area for the triangle and the largest semicircle is because actually I'm trying to find the area of these two slivers right here. I'm going to take my marker and try to highlight what I'm talking about. The purple area is what I'm trying to find. To find the purple area, that is equal to the semicircle minus the triangle. So the semicircle we know is 289 over 8 pi minus 60. Knowing that, we have found the area of the purple. The purple is equal to this right here. Now, while you can go ahead and try to plug this into your calculator, you're going to have to round because pi is an irrational number, and that can kind of mess up your number in the final answer. So instead, I'm just going to keep it in terms of pi and just leave it as it is, because eventually the pi's will cancel out and we can find an answer at the end. Next thing that we need to do is we need to actually solve for what the problem is asking for. The problem is asking for the red shaded areas. The red shaded areas are equivalent to adding the semicircles and subtracting the purple areas. So If you don't understand what I mean adding these semicircles together. That will give us the total semicircle area. Next, because we only need the red shaded area, we're going to take that total, subtract the purple from it, and we will be left with the red. So to do that, I'm going to find the area of this semicircle and this semicircle.